Hi everyone, good morning or good afternoon. This is Alagesan here. In today's talk, we'll be discussing about building knowledge graph that we built for one of our client to manage their skills and expertise of their employees, right? So on a high level, in today's session, we'll talk about what is knowledge graph and why is it needed, what is the significance of knowledge graph, and we will also discuss about modeling a RDF-based knowledge graph, and we will also talk about a real-life scenario. We will also talk about a real-life scenario in building a knowledge graph for the skills and expertise domain, right? Okay, so first, before we getting into modeling a knowledge graph, first we'll talk about what is knowledge graph, right? That's what we'll do first. Okay, so now what is knowledge graph, right? So as you can see in this right-hand side slide, knowledge graph is nothing but a network of connected entities and the relationship between them. That is what is knowledge graph. The entities can be anything. It can be it is a heterogeneous data, which means it can be anything. It can be a people, an object, image, video, or it can be anything, right? And the connection is nothing but the relationship between those two entities is what is the connections or the relationship. When you look at here, Rajiv is a software developer, right? So this is one fact that we are connected here. And here Rajiv is an entity and software developer is an object and is a connection or a relationship, right? And as you can see in this graph, a knowledge graph is usually built by connecting a set of recurrent fact. That is what is the knowledge graph there. So when you take just one portion of the knowledge graph, which is the fact here you can see that the knowledge graph terminology, we talk about a knowledge graph is a connection of node. These two entities are node, and the relationship that is connecting these two nodes are nothing but the relationship, or in the graph terminology, we call it as edge, right? So knowledge graph usually is a directed graph, as you can see here, right? So, okay, so now we will talk about what is, why a knowledge graph is important. What is the significance of a knowledge graph, right? So knowledge graph is usually driven by a big data and AI/ML based technology, because this big data and AI/ML based technology demanded a robust way to store and organize and leverage the information, right? So, and knowledge graph complements this necessity. So we are using knowledge graph there. And also knowledge graph works just like a human brain in organizing and storing the information in the brain, and you can do a faster information retrieval using the knowledge graph, right? And there is one interesting prediction from Gartner, which says that almost 80% of data and analytics innovations will be built using knowledge graph technologies by 2025. That was a prediction in 2025, but in the recent macroeconomic conditions have slowed down that prediction. But in another couple of years, you can see that knowledge graph growth can be so much explosive. Okay, so now before we get into detail, we'll just quickly talk about the power of knowledge graph, right? So power of knowledge graph, as you can see, as you all know, social network is extensively using knowledge graph to maintain the social connections between the people, right? So in the Facebook or other social networks, they use knowledge graph. And one really interesting scenario is Google's knowledge graph, which is when you search a word or a string in a Google search, Google doesn't treat that word or a string as a mere string. Instead, they treat that word as a real world entity in the real world, right? So when they give you the results, they give you the results that are related to everything else. That is how you see the data there, right? The same way Netflix. Netflix, when you search a movie in the Netflix, they also, when you search a movie, say for example, some movie you search, right? So when you search a movie in the Netflix, in the surrounding recommendation, you can also see all the movies that are related to that movie. You can see it there, right? And Amazon has something like Amazon product graph, which means when you search a book, say for example, you search a book there. When you search a book, you just don't get the book alone there. You also get all the related information about the book. How do they do it? They manage all those information about the book as a knowledge graph. And when you search that word, they simply give you all the information. So other than this, the financial domain and healthcare systems, all the systems, everyone is using knowledge graph in the backend system to build this recommendation system and all those things, right? Okay, so now we'll be getting into some technical, right? Meaning, so we will talk about how do we, one sec. Okay, so now we'll be getting into some technical in building in the modeling a knowledge graph. Okay. So predominantly in knowledge graph, there are two types of knowledge graph we can build. One is, it just keeps going. Okay, so one is RDF triple, and then there is another thing called a property-based graph. There are predominantly two types of knowledge graph we can build, right? So these two things are just mainly differing on the structure. How do we model the information or the fact in the knowledge graph, right? So as you can see in the RDF-based triple, they manage the information just like a triple, right? Whereas in the property graph, instead of managing like a triple, like we saw there, they manage the information as a collection of labeled properties. That is how they manage in the property graph. So some known DB that is implementing the RDF-based triple and property graphs are, you have GraphDB and Blaze Graph and AWS Neptune you have. And here in this scenario, you can have Neo4j and Amazon Neptune and Tiger Graph. Okay, so now going forward, we will talk about modeling an RDF-based graph. So before we getting into the details, so first we have to talk about we have to understand some terminology about modeling the knowledge graph, right? So the first we have to understand what is taxonomy, and we have to understand what is ontology, and we have to understand what is knowledge graph, right? So the taxonomy is nothing but the basic fundamental information about the real world knowledge graph is what is the taxonomy. So taxonomy, in addition to just maintaining the information, it also has the information. It also has some characterization of the information. Okay. So next terminology that to talk about is. So next one is the ontology. Ontology is nothing but the schema or the structure of the target knowledge graph, right? And the knowledge graph is nothing but the real world implementation of these two things. Okay. So in the RDF, can I get some water? Water. One sec. I have. Okay, so now as you can see in the RDF graph data modeling, so one important thing that you have to understand in the RDF graph data modeling is called triple. Right, so what is triple? Triple is nothing but if you take any fact, you have Rajiv is a software developer and Stella born in Hyderabad, and Martin Fowler, author of a refactoring book, right? So these are all facts. When you look at this fact, the subject is nothing but the Rajiv, and predicate is nothing but the Ise, and object is nothing but the software developer, right? So these two things combined, you form a knowledge graph, right? So these three elements together, we call it as a triple in the knowledge graph, right? So one thing if you can understand in this session is understanding about what is triple and how to form that triple, so that because in RDF-based graph, everything is about forming and maintaining the RDF triple, right? So now in the previous session, in the previous slide, we saw all these entities and the connections, right? So in RDF-based graph, most important thing is all these entities and connections have a unique ID, which is called the IRI. That's a basic requirement of a RDF graph modeling. So if you look at, so we have all these entities, which is Rajiv, Stella, Martin Fowler, refactoring. All these entities have a complete, fully formed URL. The URL can be formed using a simple, it can be formed using the domain name and the entity and the namespace name and the entity name. So that's how you form the entity for the given entity or the connections. Okay, so now we saw all those entities, right? So, but in RDF-based graph modeling, the important thing is you have to form them and keep them in a triple format, right? So now what we have done is we have taken all those entities and then formed as per the structure of the triple. Now you can see the left-hand side, it's a subject, and the middle is the predicate, and the target is the object, right? So this is a triple format. And most importantly, now when you look at the top RDF-based triple, if you look at, this information is so much difficult for us to understand, and it's also difficult for the human eye to understand because it's too much verbose, right? So you can use turtle syntax, or there are some other format using which you can simplify the complete triple. So this is the simplified version of the triple, in which what we are doing is we are simply just removing the prefix that we have, and the complete URL, the prefix we have removed and kept as a top prefix, and in the bottom we are just writing only the entity name and the connection name. So that's how this is first level of simplification. So now if you compare to the top to the bottom, you can understand that this one is much better in understanding for a human eye, right? And this is the second level of simplification, in which you can see that instead of repeating the subject, right? So Rajiv is repeated twice if you look at there, right? And Stella is repeated twice, and Marty Fowler is repeated thrice, right? So instead of repeating the subjects, we have mentioned only once, and the predicate and object is mentioned just repeatedly, whatever the way we wanted. This is a second level of simplification. And there you can see a third level of simplification, in which subjects are the same way we have mentioned, whereas here if you look at the predicate, the author of is repeating twice, right? So because Martin Fowler has written 2 books, so there what we have done is, instead of repeating the author of predicate twice, we have just written only once, and then we are just giving comma, and then we are adding it, right? So like this, now the target one, if you look at, it is much simpler and easy for us to understand, and even if you want to write it manually also, we can write it. So now this is some interesting concept to understand in modeling RDF graph, which is nothing but RDFS, and then web ontology language, which is OWL, right? So what if, so far we were writing all this RDF graph and everything using custom language, our own vocabulary, our own subject and predicate, right? So what if you want to use some predefined vocabulary, right? So RDFS and OWL gives you a predefined rich vocabulary to model and manage the RDF-based graph data. And here, RDFS gives you classes and subclasses and property and all these things. So using these vocabularies, what you can do is you can model your RDF graph data in an object using the object-oriented principle. So that's the most important thing you can do using the RDFS. And OWL is nothing but, so OWL gives you some more extensive vocabulary. Can you hear me? Can you hear me? Yeah, they can hear you. Yeah. So OWL gives you some more. Okay, OWL gives you some more extra rich vocabulary using which you can, if you want to give some restriction in the model. Say if you look at there at the last if you look at there, person is equivalent class of human, right? So if you want to write 2 classes in the RDFS, then you want to define that those 2 classes are equal, like person is equivalent to human, and you can such restrictions, such equality, you can write it, you can define using OWL language. And most important thing about these 2 RDFS and OWL language, if you follow in your RDF modeling, is this. It is easy for the machine to understand, right? So you can write your RDF model and you can just load it in any machine language, and machine can understand in a better way. Okay. So RDFS Star is the recent development in the RDFS graph, which is, so using this RDFS Star, what you can do is you can define a statement, you can write a definition about a statement. Meaning, if you look at there, Rajiv has role software developer, right? So that's the triple that we have written there. So what if you want to also write some more definition about that particular statement alone, right? So say, for example, you want to write start date. At what on what start date Rajiv has started the role of software developer. In which case, you can use RDF Star to define the extra definition about the triple, right? So now that we have defined our RDFS model and we have created all the model itself, so now we will try and query the RDF model using the SPARQL query. Okay, so say for example, in the in the current DB, in the database what you have developed, say for example, you have only one triple in the DB, which is Rajiv is a software developer, right? Now, what if you want to select that particular row, particular triple and get the result using the SPARQL query? So then you have to write a query similar to this, in which you can understand that we know what we're trying to do in this query is we are trying to get all the employees who are a software developer. That is what we are trying to get it here. So in this, you can understand that we know already the predicate is a and object is a software developer is what we are trying to get. And then what we are trying to fetch is the employee detail, employee name, right? So employee is the variable that you have to write it there. So SPARQL query is nothing but it's a pattern matching. In a simple terminology, it's a pattern matching. We just have to write whatever you know, you have to write it. Whatever you don't know, you have this variable parameterize and get the result out, right? So now in this query, it is fetching you just the employee name since there is only one employee. So in the next one, if you look at what that is trying to get is, we know that what we're trying to get is get all Martin Fowler's books, right? So there we know what is subject, we know what is the predicate, which is the author of. We want to get the book out of it, right? So now we are parameterizing the book as a variable, and when you run the query, it just gets me all the books that are written by the Martin Fowler. Okay. So this is if you want to get a second level detail, if you want to get it. Say for example, just get the name of the book that are written by Martin Fowler, right? So in which case you are writing, we know Martin Fowler have written some book. Book is the parameter, and then from the book we extract the book name. So you can do multiple level of extraction you can do, and now you can see the book ID is given here, and then you can see that the name of the book is also given there, right? Okay, so now we are getting into some real world implementation of our RDF graph, RDF modeling, right? Using for the skills and expertise domain. So if you look at in the current world, in the current organization, skills and expertise domain, they have multiple challenges, which is all these systems, all this data, wherever they maintain, say employee detail, role, and grade and level, skills and expertise, certification, L&D programs, all these details they maintained in a completely separate systems. All these data are siloed and are maintained separately. So now if you want to integrate them and form a unified data and get the results, it's so difficult to get it, right? And even if you want to evolve one particular data, particular information and evolve it, it's also difficult to do it, right? So this is one important problem currently that organizations are facing. So what we can do is we can implement a knowledge graph in which all this detail, whatever we saw, employee detail, roles, grade and band, all this detail, you can stream them together and you can form a unified graph data, and then we can query the data to get all this information in a single way. Then if you want to evolve those graphs also, now it is easy to evolve and manage, right? Another important point to understand here is knowledge graph, if you want to manage one single graph, you can do it, or if you want to do more than one graph and integrate them to form one single graph, and if you want to use it also, it is possible to do it, right? But now when you build a knowledge graph for an organization, the most important question that people will face is, what is the robustness of the graph, how much data you can manage, right? So now if you take an example for the Google Knowledge Graph, they are kind of maintaining close to 800 billion facts. They are managing using the knowledge graph. And there is a system called Wikidata. Even now you can go to Google, you can Google called Wikidata, which is sourced from the Wikipedia to form a knowledge base about the Wikipedia data. So there they are maintaining around 100 billion data items they are maintaining in the Wikidata. So which means knowledge graph has an extreme robustness to maintain any amount of facts and data that is there in the organization that you can manage it there. Okay, so now we will not be able to see the real demo, but instead we will be able to see the process of building a knowledge graph. How do we build a knowledge graph, right? Okay, so this is one tentative approach using which you can build a knowledge graph, right? So here, most importantly, what you have to understand is there are three major elements that are there in the knowledge graph, which is the first set of elements is nothing but taxonomy, and then there is some concept called that we saw ontology, which is nothing but the schema or the structure of the knowledge graph, and then we have the RDF triple, right? So this we have to see how do we set up our system so that all these things we can streamline, right? So the first thing is taxonomy data. Say if we are building a knowledge graph based system for the skills and expertise or for the HRM domain, then these skills and expertise detailed or data can be directly fed by some people from the organization as a CSV or a Excel sheet. You can feed it there, right? Or there are some third-party providers who are giving you these taxonomy detail. Say for example, Lightcast and WoNet, ESCO, these are some third-party providers who are giving you some taxonomy data, which you can, they have some APIs that you can hit those APIs to get the data and manage in a centralized way. You can manage the taxonomy data in your taxonomy system, right? So the taxonomy data in your organization, you can either manage it using manually, or you can use your own system. There are some third-party systems that are there using which you can also manage it. Say, for example, there is a system called Pool Party, right? Using Pool Party, you can create taxonomy, or you can streamline, or you can organize the data there. And what if there are some data that is available that is in the public, say LinkedIn or some other resume or some other place where you have skills and expertise related data that you want to streamline and use it, in which case you can also build a NLP based system which can read those data and automatically identify what are the skills and expertise detail, and it can extract and give it to you, so that those detail you can again feed it and keep it there. And then you can also, once you have the taxonomy, then you have to build the RDF triple using the taxonomy data, right? So before that, you have to build a ontology file. The ontology is nothing but the schema or the structure of the RDF triple, right? So now you define an ontology for your target graph. So and then you build your own custom system to generate the RDF triple, reading from the taxonomy data and using the ontology. Now it will spit out the RDF triple. Your system will spit out RDF triple. Now, once you have the RDF triples, those RDF triples, you load it to the graph database. So now your RDF data or our knowledge graph is built and loaded into a graph database. It can be any graph database. You can use either a Blaze graph you can use, or you can use the AWS Neptune, or you can use any graph DB. And once you have that, then you can use any knowledge. You can build any target systems to consume this knowledge graph and use it. You can have any analytic dashboard, you can build it on top of it, or if you want, you can even build some microservices that can be built using Java or Python or any, just like however you build a microservice, you can build it. There are Java and Python frameworks are there to read data from the knowledge graph, right? So using which you can build it and you can consume those knowledge graph data and use it, or you can use any Python notebook to consume data from the graph DB, right? So now, in the next few slides, what we'll be seeing is, since we didn't see the real demo, but we will see the real data files that are needed that I have previously generated and kept it there. I just want to show you the taxonomy data and ontology data and RDF triples. How does it look, and how do we load those data in the database, and how do we query and visualize them, right? So this is one example of a skills taxonomy. So like I mentioned, skills taxonomy is nothing but skills data with some categorization to it, right? So now if you look at the skills data are there in the simple Excel sheet with some categorization to it. And there you can also look at, there's a roles taxonomy data, which is nothing but some role information in an organization like Agile coach, AI data and architect, and what are their responsibility. You can also add some categorization to those roles. So these are all nothing but the taxonomy data, meaning the fundamental data of a knowledge graph with some categorization to it, right? And if you look, so there is a third-party open source tool called Protege, right? So using which you can define and create your own ontology file. As we talked earlier, ontology is nothing but the schema or the structure of the target knowledge graph, right? So you can use the Protege tool to create or generate your own. You can design your own ontology cut here. I have created multiple classes, and each class has some properties to it, and you can even define subclass, inheritance, all sort of things you can do, because using our RDFs and all, we can even define our RDF model in an object-oriented way, right? So once you define this ontology, and you can export those ontology as a text file. So that's what I have shown it there. So that is nothing but the ontology file. You can look at the person is a type of class. However, we define a class in the Java or any other object-oriented language, you can look at, it's just similar vocabulary, right? So you can define a class, and once you define a class, you can define an object or an instance to the class, and you can start using them, right? So that's the same file that I have extracted from this Protege tool. Okay, so this is nothing. Here, I have just given a screenshot of a triples, right? So these triples are generated using a custom-defined software. So we have built some software using Java or Python, and what that will do, it will read the taxonomy, and using the ontology, it will spit out the RDF triple. In the process, also you might have seen it, right? So now these are the triple detail. So once you have the triple, then you can load the data in any database. So now here we are just trying to load the data in the Blaze graph, right? So there is an option to load the file. You can just use your RDF triple to load it, and once you load it, so there you can visualize those triples using SPARQL query, right? So there, what I'm just trying to get from the triple stories, the subject, predicate, and object. So I'm just fetching all the triples from there, and then we can visualize them using the graph visualization. So that gives you the final result. So that's pretty much. If you have any questions, we can discuss.